Welcome to this tutorial on NumPy Trigonometry. Today, we'll explore the np.cos function, which allows you to calculate cosine values element-wise in NumPy arrays. The np.cos function is a NumPy function that computes the cosine of each element in an array. It's important to note that this function expects input angles to be in radians, not degrees. The cosine function is one of the fundamental trigonometric functions that returns the ratio of the adjacent side to the hypotenuse in a right triangle. The basic syntax for np.cos is straightforward. You call nump.cos and pass in your input parameter x, which represents your array of angles in radians. There are optional parameters like out and where, but the most important parameter is x, which contains the angles you want to compute the cosine for. Let's look at a simple example. We start by importing numpy as np, then we define an angle variable with a value of 0. When we pass this to np.cos and print the result, we get 1.0. This makes sense because the cosine of 0 radians is exactly 1. Now let's see how np.cos works with arrays. We create an array containing three values, 0, pi divided by 2, and pi. When we apply np.cos to this entire array, it computes the cosine for each element. The output shows 1 for cosine of 0, a very small number close to 0 for cosine of pi over 2, and -1 for cosine of pi. The tiny number you see is due to floating point precision limitations. Since np.cos requires radians, you'll often need to convert degrees to radians first. Here we have an array of angles in degrees, 0, 45, 90, and 180. We use np.radians to convert them, then apply np.cos. The results show 1 for 0 degrees, approximately 0.707 for 45 degrees, 0 for 90 degrees, and -1 for 180 degrees. The np.cos function also works seamlessly with multidimensional arrays. Here we create a two-dimensional array with 2 rows and 2 columns containing angles in radians. When we apply np.cos, it computes the cosine for every element in the array while preserving the original shape. The output is also a 2 by 2 array with the corresponding cosine values. Let's recap the key points. First, np.cos works with scalars, one-dimensional arrays, and multidimensional arrays. Second, your input must always be in radians. Third, use np.radians to convert degrees to radians before applying the cosine function. And finally, the function always returns values between -1 and 1, which is the natural range of the cosine function. Thank you for watching.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.